So hello, this is Dr. Keith Schubert with one of the video answers to a question from class. And the question had to do with one of the lines of addition inside Booth's algorithm and how did it happen. So I've tried to recreate the problem that we had, I believe from the question, that it was on the one we're doing 4 times negative 7. And it was doing it for the one in which my y was the 4 and x was the negative 7. So I've got pre-recorded 4 and minus 4, so whenever I'm subtracting it. So we start off with our initialization. At the initialization I've got 0 set in for u and v, and I've put my x value of minus 7 in, and then x minus 1 is always going to be 0 because it's, 1, 0, 0, 1, 0.0. So, and that's negative 7 and 2's complement. Alright, so what we do for each one of these is, step 1 is you check to see, these are different, so that means I'm going to do something. It's a 1, 0, which means I'm going to be doing a subtract. So I then subtract my y. So I've put the negative value of y here. Since it was 0, I didn't bother to do, add this to this because that's a result and it's kind of trivial. And then I do my shifts. So remember, this is a shift arithmetic, so the first bit gets copied. So it stays where it is and also gets shifted. All the other ones just shift. The very last one goes into the bit bucket. And then the shifting here, everything shifts to the right. So the 1 bit comes over, the 0 bit, the 0, the 1. But the 1 bit also circulates. And the reason why we're doing the circulant is not that it matters for the actual multiply, but if you track that 1 coming around, it eventually ends up back at the start. So this is, you do the circulant so that you restore the value of x and you haven't damaged them. That's going on. So that's my basic shifting thing. And you do want to make sure there was another question that had to do with why we're doing these. So just to kind of emphasize that once that happens, I always want to keep shifting them because technically I want to compare these two. That's the first step. And I want to compare these two bits for the second, third, and fourth steps. So rather than shifting where I'm comparing, it's easier to shift this number through, and then this is always the previous bit and the current bit that I'm looking at. So I can always get that comparison. When I see the 0, 1, they're different, and it's 0, 1, so that means add. So I do the addition. Now in this case it's not. And this is where I think the question was at, because when I looked at what the person had put on the question, if you notice here when I shifted these, I have 1, 1, 1, 0, and I'm adding 0, 1, 0, 0. Which when you do that, the 1 carries down. 1 and 1 gives me 0, carry a 1, 1 and the carry 1 plus the 1 plus the 0 gives me 0, carry 1, but I'm not holding the carry bit, so it gets dropped off the edge. So I get 2. Now, what it looked like on the example that the person had is it looked like they had dropped this, that they had that, which of course would not be correct. This would be negative 4 plus 4, it should be 0. But it looks like they didn't do the shift. So it's possible they just took the previous line and took that one and added, because that's negative 4. Once you do the shift, you're shifting to the right, so it's like dividing by 2, so it becomes negative 2. And negative 2 plus 4 gives me 2. So I think that was just a copy error on the part of how did those lines combine. So either that or they didn't shift or whatever. But that should be okay. The rest of them, then you just shift them, as before. When you get to the next step after the shift, it's 0, 0, so they're the same, so you don't do either an add or a subtract, you just shift again. You end up with 1, 0, so one more subtraction, but it's all zeros in the U, so that's very easy. And then you do your last shift, and you end up with 1, 1, 1, 0, 0, 1, 0, 0 as your answer. And since we're doing 4 times negative 7, it should be negative 28. If you take a look, that's minus, and then 28 is 16 plus 8 plus 4. Right, so that's 28 with a minus. You take the 2's complement, copy up to and including the first one, and then flip every bit after. You get this, and if you compare, the splitting them into the 4 bytes you get to find, you have the exact same number. So indeed it does work. And you can see that. So hopefully this answers 2 questions. Question number 1, how and why the circulation over here and how they shift, and that's how you're doing it with the circulant and the copy over. And the why is the circulant is to restore this, and the shift into here is so that I can compare each of the pairs of bits in time as it goes over for each stage. And then the addition question that was over here, I think, was a copying error of the person. So there we go. Hopefully that answers everybody's questions.